So hey guys, it's me. Um, I recently developed this habit of writing algorithm online, and after I create Rubik's cubes. So like I've been doing Leetcode for a month, like trying the medium and hard problems, and like I've been growing a lot because like previously, like I remember during senior year, I was taking AP Computer Science with Michael, and he said he could do all the problems on Leetcode, but the easy problems on Leetcode were hard for me. So like this time I really want to take up the challenge to see how far I can go. Can I be as good as him at programming? And I've been progressing really well, I'd say, through this month. So like currently I've been able to solve like almost all the medium questions and about 60 or 70% of the hard questions, depending on the difficulties. So yeah, basically, like today I'm doing a reconstruction of my problem solving on Leetcode Biweekly Contest 16. And basically, like in each contest, you have 90 minutes and you have 4 questions. The one with the higher scores are harder, apparently. The first one should be easy. Those 2 should be medium, and the last one should be hard. And so if a question is like 2 or 3 points, it's definitely easy. If it's 4, it's in the medium range, but it's also easy. And 5, it might be a little bit challenging, but if you get the idea behind it right, it's gonna be pretty simple to solve. And for the hard problems, I think, so hard problems are sometimes 6, sometimes 7, or sometimes 8. So if it's 6, it's kind of in the medium range. It's not that hard. If it's 7, sometimes it might be challenging. If it's 8, it's really challenging, and I don't see myself solving a question rated 8 during a contest because I just short of time. So yeah, let's take a look at the first question. So first one, replace elements with greatest element on right side. So you're given an array as input, like this, and then replace all the elements in the array with the greatest element among the elements to its right, and replace the last element with -1. So basically what it's saying, so if we look at the array, it starts with 1 on the right, so we go from right to left. So there are no elements to the right of 1, right? It's the end of the array. So the largest element to the right of 1 is nothing. So we put -1 here. And then we go to after we go to 1, we go to the next element, which is 6. The largest element on 6 right is 1, right? So we put 1 here. And then we go to 4. And the largest element on 4's right is 6. So we put 6 here, and so on and so on. So after we come to 18, the largest element on the right of 18 is still 6. So we put 6 there. And when we reach the last element, which is 17, the largest element on 17's right is 18. So we do this. So that's our output array. Then we look at the constraints. So constraints can be really helpful in problem solving. So usually if you see like the array length, it's like 10 to the 4th, which is 10,000. Like you definitely know that you have to do it in linear or n log n time for time complexity. Because if you try to do it in n squared time, I'm pretty sure it will be time limit exceed. Although in certain cases you might be able to like get around with that, but usually if you see this 10 to the 4th or 10 to the 5th, this is like the size, like the number range of the array. It's not that important, but like if you see the length is between on the magnitude of 10 to the 4th, 10 to the 5th, you have to do it n or n log n time. So basically you just go through the array once or like twice or constant times. You cannot like do 2 for loops, I guess. So basically I established an empty output array with the same size as the original array. Then like the rightmost element should be -1, right? Because there's no element to the right of whatever the last element is in ARR. So it should be -1 here. So I input -1 as the last element. Then I said like the TM is like the right, like the least element to something is right. So if you see the pattern here, it's like, so at first you're on 1, then you're on 6 when you traverse through the array. Then to 6 right, the largest element is 1, and then we go to 4, and to 4th right, the largest element is 6, and then we go to 5, the largest element is still 6. We see a pattern here that the elements in the output array from right to left has to be increasing or like equal or increasing, because basically like so if we observe 5 and 4, see there are 2 elements on 4th right, which is 6 and 1. So the larger one is 6, and for 5 there are 3 elements on 5th right, which is 4, 6, 1. So you see like the maximum elements to 5th right has to be larger or equal than the largest element on 4th right, which is 6, 1. Because from 4 to 5, we basically add 1 element. So if so basically like how to say this, the largest number in the three numbers has to be larger or equal to than the largest number in the 2 numbers, because we basically add 1 number. Either it's bigger than 6, then if it's bigger than 6, then the largest element would be like, so say if this element is 9, the largest element to the right of 5 will be 9, which is larger than 6, which is the largest element to 4th right. And if it's smaller, it will just be the same. Like the largest element to 5th right is 6. The largest element to 4th right is also 6. So here we go. It's also always increasing. So I just need 1 number to represent the max value to each element's right. So the TM starts at -1. Then we go to 6. And then we see 1 is larger than -1. So we update the TM to 1 and input the TM to the array. Then we go to 4. TM, because 6 is larger than 1, we update the TM to 6. So we input 6 here, 6 here, 6 here. And see when we reach 17, the largest, like 18 is larger than TM, which is 6 at the moment. So we update TM to 18. And we do this. So it's a linear solution. Basically do a for loop and like update TM. So if we take the max of TM and ARR I plus 1, which is like whatever the elements to the right is, TM is after the update, TM is always going to be bigger or equal to the previous TM. And then we input the max I to TM and return the max. So let's see. The time should be pretty quick. Yeah, okay, 99.72. Yeah, it's like you see usually the code runs within like 1 millisecond, so should be good. Next one. So it's a medium question and like not many users passed. So if like the question is easy or like in the medium range, usually like more than 85% of people pass, but this time only like 74%, so it's quite challenging, I'd say. And there are 2 approaches. One is like a log n, but mine is like linear time, so ON approach, which are pretty similar. I think both of them should pass. And I think the linear solution is pretty straightforward and easy to write. So like, so then you look at the constraint again, and you see like ARR has length on the magnitude of 10 to the 4th, which means you have to do it in log n or linear time. And then, so basically my thinking is that we first sum, like, okay, let's see. The question is asking sum of mutated array closest to target. So given an integer array and a target, return the integer value such that when we change all the integers larger than value in the given array to be equal to value, the sum of the array gets as close as possible to target. In case of a tie, return the minimum such integer. So what it's basically saying is that we are given the array and the target, and we have to create a number called value. We have to generate a number called value, or like come up with a number called value. The value can be anything, but let's say the value is 5 in this case, okay? Then we go through all the elements in the array. We see 4 is smaller than 5. See, we see 4 is smaller than 5, so we do nothing to 4. Then we go to 9. 9 is larger than 5. So what we do is we reduce 9 to 5. And then we go to the next element. 3. 3 is smaller than 5. So we do nothing to 3 again. So we come up with a value. If the element in the array is larger than the value, which is 5 in this case, then we update 9 to 5. So we change 9 to 5. And if an element is smaller than 5, we do nothing. So now our array should be 4, 5, and 3, right? And then we calculate its sum. Its sum is 4 plus 5 plus 3, which is 12. Then we calculate the difference between target and 12, which is 2. So what we want to solve in this question is we want to find a value so that after we update the array according to the value, the distance between target and the sum of the array is the smallest we can get. So in this case, we can choose 4. We can choose the value as 4. 4 is smaller or equal to 4, so it does nothing. And 9 is larger than 4, so we update 9 to 4. And 3 is smaller than 4, so we do nothing. So the array now is 4, 4, and 3. The sum is 11, and the distance between target 10 and 11 is 1. So 1 is the minimum distance we can get from providing a value and changing the array according to the value. And also, we can choose the value as 3. So 4 is larger than 3, we change 4 to 3. 9 is larger than 3, so we change 9 to 3. And we do nothing to 3, because 3 equals to 3. So the array now is 3, 3, 3, and the target is 10. And the sum of the array should be 3 plus 3 plus 3, which is 9. So the distance is again 1. And what we want to read, because you see 3 and 4 both works, because both of them get a distance of 1. So you output the smallest number. So you output the smaller or smallest number. So what you should output is 3. And if you do 2, it's going to be, the array is going to be 2, 2, 2, and it's 6. The distance between 10 and 6 is 4, which is larger than 1, like the previous best we can get. So we don't do 2, so we output 3. Okay. Again, like if you look at this example, the original array has a sum of 2 plus 3 plus 5, which is 10. The target is also 10. So we basically do not have to change anything. It's already the optimal solution. Like the distance between the sum of the array and target is 0, because they are the same. So we can basically like just choose a value of 5. And like 5 does nothing to those 3, because 5 is larger or equal to all of them. Then we reach like a distance of 0. So we just return 5. But if we do anything smaller than 5, it's going to change the array. And then the distance is going to be larger than 0. So we don't want that. So we just output 5. Okay. What I did is like I established a hash map of integer. So I'm recording this hash map, how many times an integer appeared. So say if we have an array of 2, 2, so 2, 2, 2, 3, the hash map, after the hash map goes through the array, it's going to have 2 entry of the map. It will have 2, 3, and 3, 1, which means there are 3 appearances of 2 and 1 appearance of 3. Okay. So basically what I did here is like, let's see. So after I establish the map, I start from the large, like, okay, so for example, in this case, I set my max, like I start traversing from the largest element in the array. So in this case, it's 9. So yeah, so mx is the max element in the array. So eventually it will be 9. See, like what I do here is like for all the elements in the array, max is gonna be the max of mx. Mx is gonna be the max of mx and arri. So it's gonna be the max between the previously recorded max and the ith element of the array. So eventually max will be the largest element in the array. And Sm is basically the sum of the array. So each time I add the element in the array to the sum, so in the end, Sm after the for loop will be 4 plus 9 plus 3, which is 16. And then like I basically input the value to map. So basically this function does is like if map contains a key, so if we are on this element, we previously have a 2, right? So at this point in the array, hash map is gonna have only one map entry, which is 2 and 1. So what we mean is like after we traverse this element, we have one appearance of 2. And we go to the map and see, oh, now we are on 2 after we traverse one element. Now we're on 2 again. And we go back to the map. We ask the map, do we have a 2 previously recorded? And the map says yes, because like there's one appearance of 2 before. So now we have 2 appearances of 2, right? So I basically add 1 to 1. So add the number of appearance before this 2 and add 1 to it. So there are 2 appearances of 2. And then like after I go through those 3 elements, I'm gonna have 3 appearances of 2, right? Then I meet with a 3. I ask the map, do I have a 3 recorded previously? And no, because we only saw 3 appearances of 2. So I tell the map, okay, just put the map entry 3, 1, which means I have currently map with 1 appearance of 3. So this is basically what this function does. And after the for loop, the map is going to be completely filled in accordance to the array. I just put it whatever. Then, okay, means like the minimum distance we're going to get between Sm and target, between the sum of the array and target, after we choose whatever value we want. And num, okay. Num is basically, it's kind of an interesting idea. Let's first say index. Index is like the return value we want. So like index is basically the value. Whatever, let's change it to value for easy understanding. So it's a value we choose. So we can see here, we start from the value we choose start from max, right? So in this case, we start from 9. The reason is that if we choose any number larger than 9 as a starting value, so for example, if we choose 11, it's going to do nothing to the array because all the numbers are smaller than 11. And if we choose 9, the value is still going to be still nothing will change because 9 is larger or equal to all the elements in the array. And see here, like just as I mentioned, we want to if there's a tie, we want to return the minimum such integer. So we want to return the minimum value. So basically 9 is smaller than 11. So if we don't want to change the array, 9 is going to be the minimum value and 11 won't be helpful at all because it does nothing to the array, just like 9 does. 9 also does not do anything. And 9 is smaller than 11. So 9 is preferable to 11. So we basically start our value from max. And you basically want to try all the values possible. So like what we do is like we first choose value as 9. And then we reduce value to 8 and see what happens. We reduce value to 7 and try it again and again until it reaches, hopefully until it reaches 0. So this is what our for loop does. Yeah. Then let's observe a pattern here. So see if we choose, so first we start from 9. The sum should be 4 plus 9 plus 3, which is 16. Then we choose a value 8. And 9 is going to be reduced to 8, right? 9 subtracts 1 equal to 8. So we basically just subtract 1 from the total sum, which is 16 minus 1. So we have 15 now. And we see that 4 plus 8 plus 3 is indeed 15. Then we choose value for 7, choose value as 7. And again, only this number is updated. So it goes from 8 to 7. So again, we subtract only 1 from the total sum. And the total sum is now 15 minus 1, which is 14. And we keep doing until like we reach 4. We reach a value of 4. It's gonna be 9 is gonna be set to 4, and the current sum will be 4 plus 4 plus 3, which is 11. And then we change as we change the value to 3. Those two values are gonna be updated instead of only this value, right? Because when we set value as 3, 4 is larger than 3, so we gotta update 4 to 3. So now we subtract 2 from the total sum. The array used to be 4, 4, and 3, and now we choose a value as 3. So those two elements have to be reduced by 1. So that's why we reduce 2 from the total sum. So the total sum becomes 11 minus 2, which is 9. And we see indeed, if the array is 3, 3, and 3, the total sum is 9. And later we choose the value as 2. And now we see all those elements are smaller than 2, or are larger than 2. So we have to change all those 3 elements. And see, because we are changing the value from 3 to 2, we're just subtracting the value by 1. And we are subtracting 1 to all those 3 elements. So in total, we're subtracting 3 to the total sum. And we see a pattern here, right? If we see, if we reach an element, so basically, let's say we're on a value of 4 now. The array is 4, 4, and 3. And we want to change the value to 3. And then at this exact moment, we ask the hash map, how many 4s have we seen? We have seen one, we have 1 4 recorded in the hash map, right? So we know, so we originally just update 1 element, and there is a 4 in the hash map. So we know that after we change the value from 4 to 3, this 4 is going to be reduced. So we add 1 to the total number of elements we're going to subtract. So add 1 to 1, which is 2. So we know the next step, we need to reduce 2 to the total sum. So if we look at this example, we go from value 3 to value 2, and there's only 1, 3. So it just basically change this 3 to 2. So we subtract 1 from the total sum. Now the array becomes 2, 2, 2, 2. Yeah, just that it becomes 2, 2, 2, 2. And then we ask the hash map, how many 2s have we recorded? We have 3 recorded, right? So now we need to subtract 1 from 3 additional numbers, which is this. Because like when we change the value from 2 to 1, those extra 3 elements are also going to reduce. So that's why we add 3 to 1, which is previously changed elements. So we are currently changing 3 plus 1, which is 4 elements. So next step, we reduce 4 to the sum. So that's the key idea behind num. Let's see what's in the for loop. Each time sm minus equals to num, right? That's num is how many elements we're reducing at each reduction of value. Num, yeah. So this is basically saying like if the hash map recorded any value, like so for instance, if we're on value 2, if we have value equals to 2, we ask the hash map how many 2s we have. We have 3. So num plus equals to 3. And if we don't have any, num plus equals to 0, like this. So num stays the same. And again, abs is like so now we have the updated sum, the sum of the array with according to this value. Then we calculate like the distance between them. And if like minimum is larger or equal to absolute, like ABS, so like if our currently calculated distance is smaller than the minimum we got before, we'll update the minimum to ABS, and value will equal to I. So value will be the current value we're at. So I is the current value. And the trick here, see, why don't I choose like larger, but instead, why do I choose larger or equal to? It's because if I choose larger, then if we have a tie, it's not gonna go into the if statement because they're equal. So the value will not be updated, but we want to choose a minimum value if there's a tie. So each time after we reduce the value, we have to update the value. So that's what we do. And then we return the value. So although it's like a linear solution, like it's kind of slow, probably because I used hash map, but whatever. Okay, the next one is a 5-point question, but see, oh my God, 98% of the people passed this question. So it has to be really easy, and indeed it is. So if you're familiar with the idea of binary tree or like tree, you know there's a height function. So it basically calculates how tall is the tree. So apparently, like in this case, this tree has a height of 4, right? 1, 2, 3, 4. Its height is 4. So what we do is like, so we're first on the root node, and then we see if the root is null. So if, like, for example, say if the node is here, root is null, apparently it's like height is 0 because there's nothing. But if the root is not null, say if it's here, then because like height, like either the left tree is taller or the right subtree is taller, right? So I want the height is like the maximum of the left subtree and right subtree. So I want to get the max height of the left tree and the right tree. Then I want to add 1 to that height. So for example, this left subtree has a height of 3. The right subtree also has a height of 3. So the total height should be 4 because like this node has a height of 1. So basically I do is like I add 1 to the max of the left subtree's height and right subtree's height. Do it recursively? Yeah, it's a height function. And I wrote a helper function which does the same exact thing as this. So let's see the problem. Given a binary tree, return the sum of values in its deepest leaves. So in this case, 7, 5, and 8 are leaves, right? They're on the very end of the subtree, and their left and right subtrees are both null, so that's why they're leaves. We want to get the sum of values in its deepest leaves. So the deepest, like, because it has a height of 4, its maximum depth should be 4, right, on this line. It's the deepest it gets. So this leaf 5 doesn't satisfy because it's not deep enough. So you wanna only calculate the total sum of 7 and 8, which is 15. So what we do is we utilize the height function. And I wrote a helper function sum, which does exactly the same thing as this deepest leaf sum, which is a function we want to write. But instead, I added 2 parameters. In height, which is the height of the tree. So the height input will always be 4. It will always be 4 in that case, always be 4. And depth is like the current depth I record. So if we're on this root node, the depth input will be 1. And if you're on those 2 nodes, the depth will be 2. And apparently, if I, like, when I call this function, this helper recursively, if I see depth equal to height, I'm gonna return the whatever the value is at 7, right? Because like it is the deepest because its depth equals to the height, and we're currently on this node, so we are only adding 7 to the total sum. And if root is null, apparently, if the root has nothing, it returns 0. And if the depth is not, if it's not as deep as the height, so for example, if we are on here, the depth is 2, so it's not deep enough for the height, which is 4. So what we do is like, we basically call the sum function recursively to add up all the deep leaf nodes on the left subtree and all the deep leaf nodes on the right subtree. So I add whatever sum returns on the left, whatever sum returns on the right. And here, the sum, like the recursive sum helper function on the left returns 7, right? Because on the left subtree, there's the deepest leaf node, which is 7. And the right subtree, there are no such deepest node. So I add those two up, which will be 7 plus 0, and I'll return 7 here. And similarly here, on this like, if I'm on this node, I add whatever the sum of the deepest leaf nodes are on the left and the sum of the deepest nodes on the right. So on the right, I have 8. On the left, I have nothing. So this, when I'm on this node, it will return 8. I'll return 7 here. And while I'm on the root node, it will be 7 plus 8, which is 15. So this is basically what my helper function does. So I calculate the sum on the left with depth plus 1. So if I go from here to here, it's depth 2 to 3. Yeah, so I add 1 to the depth. Same on the right. And then I just return, because the sum of, return the helper function. The original depth on the root is 1, right? So I input 1. And then I calculate the height, total height of the root. And here it goes. Pretty easy. Should be, yeah, good. The last one is pretty tricky. As a matter of fact, it's really tricky. It's number of pass with max score. 50% of people passed. It's still doable. You're given a square board of characters. You can move on the board starting at the bottom right square, marked with the character S. You need to reach the top left square, marked with the character E. The rest of the squares are labeled either with a numeric character 1 to 9 or with an obstacle X. In one move, you can go up, left, or up, left. So let's see an example. I'm gonna print out actually let's go to one node. So I start from S, and then I can choose 3 paths. I can go up. So imagine you're here. You can go up, you can go left, or you can go diagonal up. You can go like this. So X is an obstacle, so you cannot go there. So imagine there's a wall, I don't know what the fuck. There's a wall, so you cannot go there. So the only path you can take is up left, right? So if there's a 1, it means like if it's 1 to 9, it means the path is available. And eventually so basically like you want to start from X and find a path to go to the top left corner, and you want see the 1. So imagine there's a dollar here, and a dollar here, and $2 here, $4 here. So you not only want to go from S to the top left, you also want to collect as much money as you can on your way, on your path to here. And you can only go left, up, or diagonal up left. So basically you have to miss some of the cells. You have to miss some of them. So you cannot collect all the money. Yeah. What the fuck? So that's basically what you want to get. And then you also want to calculate how many paths gives you the maximum money. So for example, say this is like the max value you can get. So the max money you can get is $15 in this case. And you want to see how many different routes, how many different like paths can give me $15. So let's just assume like you can go like this and get $15. You can go like this, also get $15. So you also want to calculate how many different ways you can walk so that you get $15, which is the maximum amount of money you can get. So like the maximum, so the first part of the problem, like calculate the max amount of money you can get, is basically like, it's a typical dynamic programming of path sum, which is a pretty like classical problem. So it shouldn't be really hard if you know about dynamic programming, of course. So yeah, basically what I do, because I see this, the input is like in the form of a list of strings. So I really don't like that. I just like change that to change the whatever the list to an array called ARR, which is, it's a character array, it's a char array. So it basically like records, basically like just records the value in the strings and change it to an array. Nothing special. So yeah, like you'll return something like this. So it's exactly the same as this, but in the array form. So it's more like straightforward when you do DP. And basically we change the E. So E is like the end, but E is always on the top left. So it's like the destination we want to go to. I just change E to 0 because there's no money in the end on destination. So this is how it looks like. And so don't worry about those two functions. Those just print a two-dimensional array. This is for int array, this is for char array. Nothing special. Yeah, so this is basically what I did. I just changed the list of strings to this. Nothing fancy. And I define, yeah, I put this, I changed the E here to 0 because there's no money here. Just print it out. And this is my DP for the first part of the problem, calculating the max amount of money we can get. So basically, because I want to reduce the runtime, I basically calculated the last row and last column, the value in the DP. So basically, this is what DP looks like after calculation. So we see, okay, first, like the first pass we can choose from S is go here, right? And we reach an obstacle. And because we can only go up, left, and up, it means we cannot go to 4, because if we want to go to 4 in any way, we have to go down. We have to cross the wall and go down. So it's impossible to go to 4. So the max amount of money you can get to this obstacle is 0. Max money you can get here, get to 4, is also 0, because there's no way you can go to 4. And same for this. You just cannot go that way, because in order to reach that, you have to go up and go down, and there's no available option for you to go down. So this pass, no way, return the sum of 0. And here, same thing. You can go, if you choose to go up, you reach an obstacle. And if you want to go to this one, have to go here and here, but there's no option to go up right. So you cannot go to those elements, because if you want to go to any of those elements, you have to go up right or to the right, which is not an option. So the maximum money you can get is like 0. But say instead, if it's 4 here, so if the x is 4, then you can go to 4. You can go to 4. So the max money you can get is 4. In order to reach this element, the next 4, you cannot go up, right? If you go up, you have to go down, which is not okay. So you can only go to the left. So here it becomes 4 plus 4, which is 8. So this element means if you go to this element, the maximum amount of money you can get at this element is 8. So it means like if you go here, the max amount of money you can have in your hand at this point is 8, right? You go 4 and 4, you get 8. So this is what the DP does basically. Let's clear this up. Okay, so yeah, I just first do a DP on this row and this row, because later in the problem I need to refer back to the right down this way. I'll show you later, but I need to like refer down here. So like if we go here and we refer to the right, it doesn't work because there's no elements here. So I first do an array, like a DP calculation to solve those cells. Sure. Okay. Then, so this is what basically what I did here. If it's X, then I basically did a Boolean thing. So originally there's basically, when I start from S, there's no obstacles at S, right? So OBR, like obstacle of the row should be false. So there's no like obstacle on this path. And then if I meet with an X, which is an obstacle, I put the OBR to true. So like there is an obstacle. And like see if we have an obstacle on like this last column, all the elements up, we're gonna have a DP value of 0 because there's no way of reaching them. So if obstacle is still false, we calculate like the sum of DPI plus 1. So if it's a 4 here, and it's a 4 here, we add 4 to 4, right? Basically, we add the current money we obtain, from the current block to the max amount of money we can get from the right. So we get a total of 8. So if there's no obstacle on this course, then we do the addition. This is basically just changing the character 0 to the number 0. But if there is an obstruction, we do nothing. So the DP values remain 0 because it's already obstructed. Yeah, that's basically what I did. It's for the column. This is for the last column. This is for the last row. They're identical, virtually identical. So then here's the twist. Okay, we'll go to this later. We come here. We'll talk about this later. We go here, and basically I'm just like traversing through this row, this row, and this row, this row. So row by row, go up. Basically, like I calculate. So the max element the max amount of like money I can get at this row, at this block. Think about it. How many ways can we go to this block? We can either go from here to here, right? Or we can go from here to here. And we can go from here to here. So like essentially for each block, there are 3 ways that there's 3 potential possible ways that a person can travel to this block. See, if the person is here, you can go up and reach this block. If he's here, you can go left to reach this block. Or if he's here, you can go up left to reach this block. There are only 3 ways for a person to travel to this block. And see, this way is not valid because it's an X, it's a wall. So one could not have possibly come from a wall here too. So the only option you can have is from S, right? So the only way a person can go to this block is from S. And same thing. So the S has no money, start has no money. So like the maximum amount of money you can get is 1, right? Then if you like, so the maximum amount of money you can get on this block is 1 plus 1, which is 2, because there's only one way you can go here. Because one cannot have possibly come from a wall to here, and one cannot have possibly come from 4 to here, because one cannot reach 4 in previous cases, right? Because it's blocked here, so one cannot reach 4. So the only way someone can reach this block is from here. So basically, like if you're on this block, you have to have $2, 1 plus 1. And here, similar here is a good example. So if a person is on this block, he could have come from here, could have come from here, could have come from here, but not here, because it's an X. So if we come from here, right, person, the max amount of money a person can have on this block is $1, right? If when he's on here, when he's on this block, he has $1. So if we go up left to here, now he has a total of 1 plus 2, which is $3. And the other case, if the person is previously here, he has $2. So when he goes up, his total dollar becomes 2 plus 2, which is 4. Which one is bigger, 4 or 3? It's 4, right? So the max amount of money a person can get on when he reaches this block is $4. So this is what we do. Like, say if we're on this block, person could have come from here, come from here, come from here. And if he came from here, he had $4. So now he has 4 plus 4, which is $8. Same here, he has 4 plus 4, which is $8. If a person came from here, he has 2 plus $4, which is 6. So the max of 8, and 6 is 8. So the max amount of money a person can have when he reaches this block is 8. Then we just traverse all the elements from bottom to up. Then we reach, okay, the largest amount of money we can get is $15. Okay, that's basically how the first DP works. And here's how do I determine like if so if I'm here, there's 3 potential paths to it. How do I determine there's like no way that those paths can lead to here? I basically check if the element here is 0, right? It means there's no, like, it's impossible for people to start from here and reach there because it's 0, like it has to be blocked or something, right? Because whenever you go on a valid cell, it always increases your money because the value are between 1 and 9, 1 and 9. So if it's 0, there has to be something wrong. So that's how I determine if it's 0, I do nothing. And that's basically how I did the DP. So M is the max value of the 3 potential places that the cell comes from. So if I'm here, say, then max calculates the max of those 3 and then add it to 4, which is on this cell. And if I say like if M equals to 0, so here if like the current location is not an obstacle, and if M is larger than 0, so like at least one of the potential paths is a value larger than 0, and dpij equals to 0, then I do the calculation. But like if all of them, so for example, if all of them are 0, let's see, what's a good example? Yeah, basically like what I thought is like if all of those elements are 0, like here, if all of those elements are 0, oh yeah, this is a good example here. If all of the elements are 0, like if I'm on this cell and all of the elements are 0, this means like I have no possible way of reaching this cell because all of them are blocked or something. So the max money I can get here is also 0, no matter if it's a 3 or not, because I cannot reach this cell. So it's impossible. It's still 0. So this is what I did. But here's the catch. If we start from an S also doesn't have money. But if we move here, it's okay, right? Because although S doesn't have money, it's a valid block. So I have to do a small check. So here's what I did. This is like the exact scenario. Because in this case, like in this exact case, those three will be 0. This 2 will be blocked and this will be 0. But the good thing is like, this can only happen when this 0 is on the very bottom right of the array. So I just check this one case. Just check this one case. And then like I say here, so if dpij is 1 in this case, because I updated already before I do the for loop, then it's not gonna change the element as 1 to 0. Even if it sees like all those three is 0, it will not change 1. Because here, 1 is already defined, it's already larger than 0, so this doesn't pass. So it doesn't change anything for the 1, which is a win for us. So we do the DP. And now we have the max element, which is 15. Yay. And then then what we do is like, we want to know how many passes lead to 15. So we go back to a DFS. So if you look here, the because it has no money here. So in order to like be a valid pass to reach 15 here, like it's like the previous location a person is at has to be this or this, right? Because if a person at here is 13, if he's here, then when he goes here, when he goes to the destination, the total amount of value is 13, which is not what we want. We want the number of ways of having 15. So this is not valid. We cannot go here. So we can go here and here. Let's see. So we're on 15 here. Then we go and see. So I'm on this cell and I have 15. So if I go to its if I go back to my previous position, the sum has to be 13, right? Because I receive an extra $2 when I come here. So the previous has to be 13. If the previous is 8, for example, then after I get to it becomes 10. And 10 is not the 15 we want. So the previous had to be 15 minus 2, which is 13. We see only one valid value is here, which is 13. So we can only go this way, right? So 13, we obtained $5 here. So in previous step, we have to have $8. Because you have, for example, if you have $6, and 6 plus 5 will be 11, which is not the 13 we want. We want the max value. So it has to go here. The previous one has to be here. Those two doesn't work. So it's like a valid pass here. So basically, I want to know how many valid paths can come from this 15. How many ways can I reach this and get 15 here? How many ways I can reach this cell and get 15 at this point, at that point? So you see the idea? It's basically like check if this is 15, go down, go back, and see how many ways we can get to this 15. And add the number of ways to get to this 15 to the number of ways we can get to this 15. Add them up and we get the number of ways we can get this 15. So we go recursively back. And yeah, let's see. This is what I put in for DP2. This is like a DFS function I wrote. So if X, Y is like the row number, X is like the column number. So if those means X, Y are out of range for the array, then we return 0. If it's an obstacle, there's no way of reaching it, so we return 0 because there's no way. And if target doesn't equals to the value on DP, which is the DP array we calculated. So for example, say if like we have 3 potential paths to come to 15. And basically we check like if it's not 13 here, it's not 15 minus 2, then it's impossible to have come from 8 to 15 in this case. So those values will return 0, and we go down this path. And this is like, I don't know what I did here. Target is smaller than 0, which is impossible. And if target is equal to 0, so if it's here, I return 1, because there's one path starting from S, right? Originally, you only have one path, so you only start from one block, so it's 1. Yeah. And basically, it's like a memoized solution. So if I already calculated the number of ways you can reach this element with the possibility of reaching 15. I don't need to calculate it again because I already calculated the value. So that's basically what I did. Then I just checked. I just added those potential. So those are like 3 directions I could have come from. I added the number of ways you can reach the maximum values. Add the 3 possibilities together. And I do it with mod because like the number of ways can get really large. And he told us to take modulo like this. So I took the mod. Yeah, and I'll show you what DP2 looks like. So eventually DP2 looks like this. So see, like we start with one path. We can only go up to here. Or like we can see, we can only go up to here, right? So there's one path here. And because we can only go up to here, like the max has to be generated from this path, right? There's only one available path from the start. Then there's one path here, straightforward. And I can either go here. At this element, I can go here, or here, or here, right? So if I go there, there's one valid path that could lead to 15. Same here, one valid path to lead to 15. And here, because like there's one valid path here, one valid path here, they can both go here, so it's 2, right? And if we see if we are at 4, remember this DP value here should be 8. And if we go this path, 8 plus 3 plus 2 is 13, right? We cannot do that because we want 15. So that's why there's no way to land on this cell and get 15. So we put as 0 here. So they add up to 4, which is the correct answer. And in an easier example, if we look at this, the largest amount of money we can get is through this path, right? 2 plus 3 plus 2, which is 7. So there's only one valid path like this. If we go here, no, it's 5. So yeah. Okay. Yeah, basically like the DFS recursively calls the right bottom elements and calculate them. So yeah, it's a hard problem. Requires you to do both, like, I mean, you can do both as like bottom up DP, or like you can do both as DFS plus memoization. But yeah, I just found out like the second part to be easier if you do a DFS. So I just did it, and it's pretty good. Yeah, let's see the time. Yay, 100%, which means like this program is really optimized, really running fast. Okay, so I want to do a conclusion on this contest I did. Like I did it as a virtual contest because I just want to see how I do under pressure. And something interesting is like after I solved the first 3 questions, it only took me 10 minutes. So at that time I was placed at number 6 out of like 10,000 people. But I mean, I think I'm just like quick on easy problems. But because like I haven't done a lot of, like I'm not very experienced in programming yet. So like the last one, I thought it's gonna take me 20 minutes, but instead it took me 50. So I ended up being like, 275th. Yeah, it's not that good, but it's still some improvement. So I'll call it a day here. Thank you guys for watching, and hope you learned something today.